Actually, this story about like code reviewing and reading your comments like really resonated. Like, who wrote this code? Who wrote this comment? Oh, it was me like 5 years ago. Oh my god! I even like had was a story that I was thinking late night. What's like the most optimal strategy in battleships? You know, this game where you put like ships and you shoot one A1, B5. I was thinking, what's the most optimal strategy? And I like searched it in Google, and I searched Google, and I found like some Yahoo answers somewhere, per the same question, and there was like a marvelous answer, like with a PDF, with computed like the mathematical probabilities, everything like well described, and was like amazing. And I discovered it was like me who asked this question like 5 years ago, and it was me who answered it. So yeah, like our brains are foggy, and this can happen. All right, so to the subject. This is my second time, and today I want to talk about dependency injection. And first of all, I probably want to ask you how many, like maybe let's do a quiz, like a warm up. Who's using TypeScript? Great, okay. React, Vue, okay. Angular, okay. Anything else? Great, 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 great. All right, so I know that you can use your hand now. That's cool. The next question is, well, do you think you know what dependency injection is?
Yes.
Probably. Okay, good. So maybe you can, I can show you something. Then maybe a question: have you like anyone you've like tried or heard of any dependency injection approaches in JavaScript or some libraries you know? Do you have some experience with that? All right. So I really hope I'm gonna share some experience, because my goal today is to share my experiences because well, I work at PackHelp as engineering manager, and we've been mainly responsible for, well, okay, I'm telling you what PackHelp is. What we do at PackHelp, we sell packages. So we're basically an interface to the old world of big printing houses. So a client wants like a package and he doesn't know what to do. He picks up the phone, calls to the printing factory, and they say, oh, you have to send us PDF in SMIC format. What's SMIC? What's SMIC, right? They don't know it. And what we do is provide like a simple interface for them to order packages. And the application grew in complexity, and we started to have this architectural issue. So my job at PackHelp is I basically do this editor. It's like an online tool. Let me, maybe it's gonna play the video. All right, so this is like a demo. And what you see here is a combination of like many layers of architecture. First of all, you have this 2D and 3D element, like you see this like packaging. Then you have the React layer. The interface is powered by React. And then you have a lot of like custom business logic written in plain JavaScript, TypeScript, classes and instances and stuff like that. And you also have some glue code to merge and create interfaces between all those layers. And so this is the problem that we had, that this editor like grew in complexity, and it had like new approaches. For example, we see here the client side of the editor, but we also have the editor mode for our designers who create assets, and then you can just hit the buy icon, hit the buy button, and get this order to you delivered like in 12 days or something. So it's like simplifying the process for the clients. And yeah, we have this designer mode, what we call, and it doesn't really like require all those e-commerce elements related to like pricing, volume, stuff like that. And we had to like, the application was growing, and we started to hit some architectural limits. And hence the dependency injection. So back to the point, dependency injection. So why bother? Because our app grew in complexity, and we had to find some solutions to make it like pretty and organized and lean and efficient and everything related. So yeah, this is like architecture. There are like layers, and they need some order, and they need some order to work optimally. And there are some techniques to dependency injection. I will show some code, and we'll run pretty quickly through them, so pay attention. So what's dependency injection? Like the simplest form. It's first of all, if you know solid. So like dependency inversion principle is like one of them. So basically the idea that you somehow provide the instances or tools or dependencies that the other part of the application needs. So for example, we're making import, you're basically like getting dependencies to the code that you need them. Or in constructor, you add arguments in your constructor. That's like a form of dependency injection. So it's somehow connecting the elements together. And formally, I would group them generally into context-based dependency injection. So for example, when you do Windows something and like assign like some variable instance to a window and then reference it, it's like getting from a context. Or like global Node.js context. It's like you're getting your dependencies from the context, like process. If you're in Node.js environment, you're basically saying process.end.something. It's basically it's a dependency injection on the. If you're in React, you say use context. It's dependency injection based on the context. You climb up the root tree, and this is the context. So it's context-based dependency injections. Also, maybe like lumping some service locator pattern, but don't want to go there tonight. Also, there are techniques with setters and getters. So like public properties, where you can like put dependencies. For example, I'm going to reference an example here. So imagine you have some payment service that has one method, send money, and you want to log it. And you need a logger and you want an instance of a logger. And when you're developing, you'll have a console logger. In your production, you might have some production, Sentry, Pinot, whatever logger, Winston, Boolean, whatever you want, some production logger. And in test, you want some like, mock silent logger, right? So you depend on the interface and not on the some specific implementation. And you can like inject them via setters methods. And constructor-based injection, I think it's like a good classic, and it's like a safe default for most use cases. All right, let's go through them. So first of all, do you have this? All right, So we have here an interface. It's like a good spec on an interface and not like on specific implementation. And there's like two mock implementations of the logging service. Then if we would do this in a context-based injection, we can have something like this. So we may have like it in a window or in a specific like, singleton thing or some service locator like or a library like pattern that we have like context here. And then we refer to the context in our class. So this is like one of the ways you can do it. The second way is you can have some like inject somehow during when the, for example, when the class like becomes an instance, you can somehow like inject it via public getter or even directly in the so there are ways to like inject it after creation, instance creation. And then there is like a good classic, I would call like give it in a constructor. It's like one of the best, most rock solid and most like recognized pattern. And it will play very nicely with all the TypeScript and all the static analysis with tests and everything. So this is one of the good classic, and I would recommend like using this one as your first option. So this is like the base. And yeah, so we depend on the interface, not on specific not on an implementation. And yeah, so this is the base example we're going to use, a payment service that has like one dependency of a logger. Right. Then and dependency injection has like long roots. It comes from other more mature languages like Java, C#, Objective-C, all the other good languages. The JavaScript, like the bad part and the good part. The JavaScript book is this thick, and the good part by Crockford is this thick. So from other languages, dependency injection is basically a solved problem, and the techniques are well known and they work great. And basically, there are two techniques how they work. In Java, they work mostly on reflection API. So basically the JavaScript VM knows what kind of instances and classes are there around, and then can like find them. In PHP also it works like that. And for example, in C#, the compiler, in the compile, generates some code that basically does the same as reflection, so it's even more performant. And basically, it just solves the problem. It's not a problem in JavaScript. That's all. So, for example, this is Java code. I'll explain what it means. Basically, we have like two classes: business logic. We define the business logic like lemon and orange. Then we have like a juicer. It depends via in a constructor. It's like a constructor-based dependency injection. It depends on those instances. And then you create what's called like a container. In different languages, you call it the same, but the idea is always the same. You create some container, some zone, some instance, something to hold, to attach to your classes. And you create this container. Then you add those classes to this container. And then like a very cool thing happens. If you ask get component of a juicer class, the Java will know that the juicer needs the orange and the lemon types, and will find types of lemon juice and create those instances for you. And this is amazing because you, as a developer, you only have to declare your dependencies here in the constructor, and the VM and this Pico container, this dependency injection framework, will figure out how to create those instances for you. And this is like one of the best like implementations with this. So there are two distinct parts of this flow. First of all, you define your business logic. So it's like you write your code normally, you have your constructors depend on something. Then you have like step two, like wiring binding logic, where you basically say, okay, dear dependency injection framework, please look at those classes and they're somehow connected, and then figure out how to connect them. And then you as a user just write something like run my app, and everything like runs. So this is the Java holy grail. Let me check the time, okay. So what are like the real options when it comes to JavaScript? And it's like opinion part. First of all, use constructor injection as much as possible. It's probably the safest, most convenient. The TypeScript will be happy. It's easy to write tests. Don't use singletons, you'll kill your tests. So this is it. The second thing, yeah, this is the good pattern. The second thing is when it comes to like the dependency injection, manual dependency injection without a framework is the simplest and most preferable. So I'm gonna like make this example a little bit more complicated. So we still have our loggers, right? And let's have some auth service, user class, and like payment service class. So, and it becomes async. So what we need here is we define our business logic like this. We have some user data interface, an authentication system provides us with some user data, right? Then the user depends on a data type of user data that we have here and here. And the payment service needs a logger, you remember our logger, and the user instance. So it's like a pretty simple dependency tree. And it's really clear what depends on what. It depends on interfaces, not on implementations. Those classes are swappable. Pretty simple, straightforward to read. So this is your business logic. Then if you do like what we call manual dependency injection, or poor man's DI, sometimes it's called, you basically write code like this in your index.ts file or something. You create an instance of a logger. Depending on the environment, it's one or the other, right? Then you manually create the instance of an auth service. Then you execute an async code, and it goes like here. You can read code. So this is simple, straightforward, readable. And this is a very good strategy, and I would recommend you to stick to it as long as possible because it's readable, everybody can understand it, there are no issues with it. Then if you have some like growing pains, you might be tempted or want or need or have to use some sort of dependency injection framework or some more advanced dependency injection approaches. So this is my thing. I want to share my experience and like the pains and the gains and the tears and hacks and solutions, possible solutions, what I came through, so you don't have to. So for example, if you're using dependency injection framework in TypeScript, your code might look then something like this. So this is in Versify.js, you like add some decorators that will be used by using Reflect Metadata API that might be eventually merged into JavaScript. Now we have like huge polyfill for that. If you do this and then like do this binding phase like here, like something similar like we had in Java, you do those bindings to some tokens, and then you can have kind of the same like experience like we had in Java. But there are like, so this is like a framework approach. So you see that you have to change your code profoundly and adapt it to a framework. And this is like, this is the downside of using a dependency injection framework approach. So if you want to use it, you really should think twice about it, because it will kind of pollute all your code. So it's kind of like you would have to extend all your classes in all of your code with the framework and make them dependent, make your business logic dependable on some weird framework. It's a weird trade-off, but you might have no other option. So my opinion, use manual DI as long as you can, because it's simple. But if you need more, and what are the frameworks out there? What are the pros and cons? How they're constructed? How do they work? And what's my experience with them? So I would go with some types. So some of them are built in, and this is actually great news. Angular and Nest.js have like a built-in dependency injection frameworks, and they're okay. If they're built in, they work, they provide value, they are like merged into their framework. It's okay, they're fine. It's acceptable to use them. I think that they're okay. Like not much comment there. The second is the one that rely on decorators. And if you're gonna search like JavaScript dependency injection framework, Versify.js is gonna be like the first one to come. And probably the second most popular is TS-Syringe by Microsoft. It's much better typed. Probably it's the same company that makes TypeScript, right? It's like the second class, and honestly, trust me, I have like npm installed probably 100 of them, of different like DI frameworks. So like can tested them, look through them. So it's like classification. Then there are ones that do some weird, very tricky, weird, cool compiler hacks. Basically, they hack the either Babel or types compiler and try to extract information about the types, about the interface from them, and give you like dependency injection via that method. So basically like some compiler hacks. Or there are also ones that just read your source code, the Node.js ones. Sorry. They literally like, open your files, read them, parse the source code, parse the tokens, and try to guess what the dependency is. So there are like those kinds of frameworks. Then there is like property hacks. I think there's like a very nice I found like called typed inject. Basically, it does the same as decorators, but it uses JavaScript static properties instead of decorators, and kind of achieves the same result. It's a very good one. And there is like the last one, like manual DI on steroids, or on the rocks, or on Rails. How would you like it? It's a little bit different, but very useful. So built-ins are okay. Decorators. This is in Versify. Yes, I've told you about this. So basically, this is how your code is gonna look after in Versify. And what's the problem with that? First of all, you'll have a Babel config issues, because first of all, you'll have to support decorators, and you know that the standard is changing. There are, I think, right now 4 or 5 competing standards, and this is going to be a mess if for your Babel config. Second, the dependency on decorators. You might not want it. It's not still in the core of the language. TypeScript decorators aren't compatible that are going to come to JavaScript, so it's going to be like a clash. So it's like a risk factor. Those decorator libraries, they don't support async flow. And guys, like, I don't know what they're thinking, but JavaScript is async. How the hell would you not add async as a core of your library that does dependency injection in an async language? It's insanity. And the saddest part is they don't work with the like built-in default, how do you call them? Boilerplates, right? Like create React app, Next.js, stuff like that, because they don't have the built-in decorator support. But if you have like TypeScript, it kind of does. But then you have to depend on the reflect metadata and hack it into Babel. And then all your like setups you'll have to eject from create React app or provide some ugly hacks. And I wanted to once add decorators to Nest.js, and I spent like 5 or 6 hours. And I've been using Webpack for, I don't know, 8 years or 6, like from the first version when it was even Square, and I like couldn't do it. It's a waste of time. You can like spend too much time on like, adding this support to your Babel, or like your Webpack config or rollup or anything. And so it's like the issue with them, with those libraries related to the dependent decorators and reflect metadata, is that it's a heavy cost on your tooling, and it's like not easily to move them across projects, or because one project may use rollup, they may use Webpack, and they may be like not compatible. And they may use then different decorator standards, and you're gonna shoot yourself in the head with it. So this is a real risk. But if your flow supports it, and you have reflect metadata, and your Webpack is small, you can use them if you like this approach. So this is like one lump of them. Compiler hacks is basically what compiler hack is. It's the same as the Java code. I didn't want to like put too much code in here related to Debkit, but you know already this code. And you can write the same in TypeScript, and the library like called Deepkit.io, and some of them can turn this kind of code like this into like a working code. But the risks are that, again, it's Babel and TypeScript config issues because they hack into the compilers. They don't work with the built-ins, and your code will be unique Snowflake alien, and it will not work. Like other people don't know, it will be like a language hack that nobody knows why it works. So this would be like a very not really transparent. So those are the downsides. Property hacks, I think I like this really much, this approach, because what it does something like visible. It's not like, it's very explicit. You defined a property inject, and then you have some like related tokens, classes related to tokens. And this library will kind of provide you with like create the instances of the parent classes, not the parent classes, instances of those classes, and we'll inject them. It's a very nice library. This guy is like really smart. It's one of the best written libraries I've seen. Very well documented. The TypeScript code is really nice. So I would give it a try. And the downside is that you will kind of pollute your code with this inject thing. Is it 1 minute?
1 minute, yeah.
Oh my God. Okay. I thought I had like 30 minutes. That's 25. Okay. So spotty TypeScript, no native async support. And the last thing, this manual DI I've talked about previously. And I didn't like neither of those approaches. And I was staying in hospital, and I was like bored. And so I wanted to solve this problem like in the most elegant way I could. And I did something, and I wrote this like ATI library. And it has like ticks all the checkboxes. It doesn't need, I don't have time, so it doesn't like require any Babel hacks. It's like super type safe, and it supports async. It's just 1 kilobyte. It's friendly with all the starters. And it's really simple. If you're moving from the manual dependency injection code like this, that you probably might already have, into something like this doesn't really, it's almost the same, and it supports async, and you basically get almost this Java-like experience and includes async. So to summarize, takeaways from this presentation, use constructor injection. This is the lessons I've learned. Use constructor injections. It's a good approach. It works most of the time. Manual DI as long as you can, because dependency injection frameworks can be complex and they can really come at price. And if you need DI framework, shameless plug, check ATI. It worked for me, it worked for the company. So thank you for your time.